All right. Good morning, everyone. Thank you for attending today's Solar Oregon Green Energy Series. And today's topic is your roof solar ready? My name is Mark Farrell. I'm an NABCEP certified solar professional. I've been in solar since 2010, so this is my 14th year, and I'll be doing this seminar today. A little bit about Solar Oregon. It's an education, outreach, community, and advocacy organization. Basically, it's a public-facing organization to help you go solar. They have solar tours, they have solarized campaigns where you have neighborhoods get together and go solar together to get a little bit of a cost savings. And of course, peer-to-peer education. Solar Oregon's been around 40 plus years. So they've been around a long time advocating for solar and storage these days. So you could donate and become a member at this site here. I've been a member since 2010, so I really I'm a big advocate of this organization, and I really enjoyed it. They've done a great job over the years. And speaking of solar and storage, the next webinar will be March 7th. That's a week from today. Now, right? A week from today? Today's the 2nd. 6 p.m. online. Oh no, actually, that's like Wednesday or Thursday. And then after that, April 6th, there'll be another part of the series, Build Tight, Ventilate Right. And that's Saturday, April 6th. So again, lots of great webinars. You can attend live, as you may be doing today, or watch it later on in the recording. So today, is your roof solar ready? Here's a photograph actually of my home here in Beaverton. And I went solar about 4 years ago, solar and storage actually. So I've got a lot of experience in residential solar installation. First thing I'd like to talk about is when educating the public is the fact that Oregon has its own solar code, which is unique. As far as I know, there isn't another state that has adopted a code yet. Some of the reasons, the goals and the scope, clear and simple code. We do need a code to make sure people do this consistently. It provides great installation statewide. It does eliminate some barriers to local approval, meaning if your permitting office, it provides some sort of consistency from permitting office to permitting office, which makes it easier for the installers to figure out what they need to do. At the moment, it's for PV photovoltaic systems only, but storage may be coming up in the future. It was implemented in 2010 and revised in 2018. Again, first code in the nation, and a big part of it, it's a very long code, but a big part of it addresses what's called light framed wood construction in a prescriptive path and a non-prescriptive path, and what that pertains to the roof structure, and we'll get into that later. But I wanted to know, this is one of the most important parts of the code and something that's really looked at carefully. And finally, it provides for firefighter safety. It's one of the things that came up before 2010 is firefighters were saying, hey, people were filling up their roofs with solar. It might be a nice thing for them, but if there's a fire, if we need to get up there, it could be difficult. So part of this has firefighter safety in it. And what that means is it requires certain setbacks, meaning from the edge or from the eave or from the peak, you have to have a certain amount of room so that the firefighters can get up there and do their work. And we'll take a look at some of those pathways right now. So basically, what the code says, and the reason we're going over this is you may wonder, if you're working with a solar installer, why can't I put more solar over here or over there? Well, it really has to do with this code. So what it says on the left here is if your solar array is less than 25% of the total roof area looking down, like in bird's eye view, all you need is that simple 12-inch or 1-foot pathway on the ridge, because the assumption is there'll be enough room for firefighters to get on the roof from the eave, because you're only taking up 25% of the total roof area. However, if the array is greater than 25% of the total roof area, you do need an additional 3-foot pathway from the eave to the peak. And again, this is one of the reasons why sometimes your solar array might be a little smaller than you wanted it, because we do need to have these pathways. There are a few other small items regarding pathways. For example, you can't put the attachments in an overhanging eave. So that's the part of the roof that may overhang from your outside wall. The solar module can go over that space, but you can't have the attachment in that area. So there's a couple of nuances there, but this is the main reason your array might need pathways. One thing I like about this code is it makes these the solar arrays look better. Honestly, some of the older ones you would have installers, running modules over the peak. They'd be running over the side. It just didn't look very good. But so our systems tend to look better than the older systems and systems installed in other states. The permitting universe. One of the things about, so this is a permanently attached system to your home. So permitting is important. It starts with the Oregon Solar Installation Code that I mentioned a few slides ago. There is a permit process. You have to go to your permit office, whether it's your city or county. There's a cost to that as well, and the costs do vary greatly. Some counties, it may be $85. Other areas, like the city of Portland, it could run into the hundreds. And your installer should be aware of all this. It shouldn't be an extra cost. They should already know exactly how much it's going to cost, and that will be in the pricing. There's also zoning and land use. Sometimes you may, in the city of Portland, we have historic districts, and there are certain rules around where you can put solar modules. Those change over time, and they've loosened up a bit in the recent past. But before then, it was very difficult to get solar if you had a home in a historic district. When it comes to land use, that may pertain more to ground mounts. So I've done residential ground mounts in very rural areas, and you might have issues with wetlands. You might want, I want to put my solar array over there, but the county, the permitting officer, well, actually that's a wetland, you can't actually put it there. So there are specific things that your installer needs to research before he actually prices things out, to make sure that you can put the array where you want it. And finally, at the bottom, aesthetics. Aesthetics, that's a judgment call, but I believe it's very important. I think that the system should look good on the roof. It shouldn't, have an odd design. It should, all the rails should be snug up to the side of the modules. It's got to look good, because that, again, it could be very obvious if it's on the front of the house facing the street, and someday you may sell the house and you want people to say, oh, that's a great looking array. I'm glad I have solar. That's going to reduce my electricity costs. HOAs. So a lot of communities have HOAs, and they have rules and regulations, of course, for all sorts of things. In Oregon, we're lucky enough to have a statute that actually prohibits HOAs from saying no to your solar project. Having said that, it's always nice to play nice. So my suggestion is, if you have an HOA, find out if they have any issues, or if they have certain basic requirements. Get the form. Everyone's got a form these days. Make sure you file it. And you may have an HOA that's very simple. They're like, okay, sounds good. But then you might have one that could be very difficult. For example, I had an HOA a few years ago where there was one member of the board who was very opposed, honestly, to solar, and made us jump through all sorts of hoops. Even at the end of the day, I had to bring one of the solar modules that we were going to install into one of their meetings to show them what it would look like. It was, it was kind of crazy, but again, I was happy to do it. And at the end of the day, he was able, they approved it, which of course they had to. But that was the first array system in that HOA. I found out later. That's one of the reasons they were very cautious. So just be aware of that. HOAs can't say no, but it's always nice to play nice. So roof types. The reason I'm bringing this up is this can this can determine the size of the system that you have, that and which way it faces, whether it's east, west, or south, or north. Obviously, south is the best. East and west can work quite well, especially with lower pitched roofs. But most of the time in homes that I find, I would say pre-1970, a lot of those are the gable type. If you look at this this picture, it's the ones at the top in the middle, the open gable and box gable, and those are great roofs because they're very large, not a lot of no angles to them, and you get a pretty good array up there. Sometimes they might have a dormer. You see that the gable with the dormer over there. And of course, hip roofs are popular as well, especially on, well, on my house, I have one that was a 1950s ranch style. These days, the hip and valley, second row to the left, that's very popular, as I think everyone knows. If you look around, there's a lot of hip and valley roofs out there. The challenge with those is you will probably wind up having sub-arrays on a couple of different of those roof planes, which is fine. Again, try to make it look as best you can. And it could impact the size of the system because you have a larger home, you have a hip and valley roof, and you might not have a large expanse to put up solar like you have with the gable roofs. There's a number of different roof types here. You can find yours here. Oh, by the way, if you're sitting out there and you've got, oh, I've got a gambrel roof, I didn't know that's what it was called, or a mansard roof, just know that it's probably going to be impossible to install solar on that very, very steep section. In fact, I would say it is impossible, only because well, first of all, from a safety standpoint, it's hard to do. But second, and more importantly, is the racking manufacturers. Those are the manufacturers who have the attachments and the racking systems for the modules. They will not warranty an installation on such a steep roof. You see there's a flat roof there. We could definitely do flat roofs. That's not a big deal. And some of these other roof types, again, it's popular. Shed roofs are great too. And if you have an outbuilding, we've done a number of shed roofs over time. We've also done some ADUs that have that shed roof design. So roof types. Now, what about roofing materials? Well, there's a lot of different roofing materials that we can definitely install on. And first and foremost, on the upper left is your asphalt composite shingle. That's the most popular roofing that we have here in Oregon, and it's the easiest one to install on. And what you're seeing in the top left, that's what's called like a 30-year roof, and that's very typical. That second roof in from the top left, as you can see, has more of a three-dimensional look, and that's called an architectural or 50-year or sometimes lifetime roof. We can definitely install on that. It's a little harder only because those shingles are very, very thick, and it takes a little bit more effort to get the attachment on that roof, and we'll talk about the attachments in a moment. Still on the top row, third from the left, that's an asphalt roof. It's rolled asphalt with sealed edges, as you can probably see there. And again, we can definitely install on that. There's a special type of attachment that screws into the roof deck, and then there's a sealant that goes on top of that. The one all the way to the right on the top, that's the same sort of roof, but that's got like gravel on it. And we've definitely seen that. Again, it's not a big deal. We just have to push the gravel out of the way. Let's go back to the left on the lower line there, and that's a metal standing seam. In fact, the second one in from the left on the bottom, that's a close-up of a standing seam. And basically, that's a metal roof that comes in sheets, and then they crimp it together to make those seams. And that's a very popular roof, especially in more rural areas, especially in areas where you've got a lot of snow. But we can definitely install on them. And that third from the left is also another type of standing seam metal roof. As you can see, there are many different types of seams, but the solar industry has figured out specific types of clamps to clamp onto the different types of seam. And we'll see those in a few minutes. And finally, that last one to the bottom right is called TPO. It's like a vinyl roof, basically. It's glued down, and the seams are heat welded together. And there is a product out there that we can install on that as well. It lags into the deck, and there's a sealant, there's like a boot that goes on top of it. If you're replacing one of those types of roofs, you might even consider doing solar at the same time, and then your roofer would be able to seal those attachments, which would then be part of his warranty. And we've had people do that. So those roofs are all good to go. Some roofs are not good to go. So what we're looking at on the left is a metal shingle roof. And those, it's not that you can't, it's that most installers won't, because it's very, very difficult to install an attachment on that roof, mainly because you have to penetrate through the metal roof with a special type of screws. And usually for each attachment, you might have 8 screws. And if you have, let's say you have 20 solar modules, and on average you need 2.5 attachments per module, that's 50 attachments times 8, that's 400 screws. So you're putting 400 screws in your nice metal roof. So that's why most people won't do it. If you're putting on a metal roof, the last thing you want to do is penetrate that material. So the second one, the one in the middle, is like a tile roof, you could call it. It could be ceramic, could be concrete. And even though, you know, that's very popular in the Southeast, and there's lots of solar on that type of roof, and yes, it's absolutely doable. What we found is in Oregon, there are very few of those. So the installers don't have any experience. So typically they'll pass on that. And there might be someone out there who would do it, but most will not because of lack of experience. So that's the only cautionary tale there. I should have put up a cedar shake. I forgot to do that. And cedar shakes, most installers will pass on that as well, only because it's just hard to work on. And again, we don't have a lot of experience doing it, and you need special sort of attachments for that. And if it's an older roof, it's very fragile as well. So most folks will not install on that. The last one I've got to the right is a plastic roof. It's a plastic shingle. And again, that's a tough one too, because you might use those same sort of attachments that you did in the metal roof, and suddenly you've got all sorts of holes in your plastic roof. So that one we're going to pass on as well. So roof attachments, let's talk about those. Now this is for the standard asphalt comp roof. What you're seeing there is in the upper left, that flat plate. It's an aluminum plate. It's about 12 inches long, and it slides up and under the shingle. And as you see in the lower left-hand corner, that installer is sliding it up there. It goes up to the next shingle, and then about an inch or two into under the shingle above that one. And then they'll take like a 3.5-inch lag screw, and they will lag it into your rafter. And that's very important. According to the Oregon Solar Specialty Code, it has to go into the rafter. So they actually have to find those and make sure that they hit that rafter. That's key. And then they'll screw on that that top piece where the rail will then go. On the right, you'll see one of the attachments for that standing seam metal roof we talked about earlier. And as you can see, what it does, it grabs, it's got those 2 screws, and it grabs onto that seam. and then you would mount the L-foot, as you can see in the lower right, just on top of that with your rail. And that's how those systems work. It's going to dimple that seam just a little bit to make a real positive contact, but it will not crimp it. In the past, there was an issue with some of the attachments crimping certain types of seams, but the manufacturers have figured out how to get away from that to actually design one that will not damage that standing seam metal roof, because that's very important. I wanted to mention, going back to the left on those roof attachments, it will not void your roofing material warranty. When it comes to roofing, there are typically two warranties. The installer, your roofing contractor, will give you like a 1 or 2 year warranty, but the manufacturer typically gives you a 25, 30, 50-year warranty, something like that. And because we're using what is called generally accepted roofing practices, it does not void your material warranty. So that's very important. I even got a letter from, I think, GAF, that's a roofing manufacturer, I think in 2015, stating those exact words. So you're good to go there. Some other attachments, and one more roof type I wanted to mention. This is a corrugated roof on the right there, and also on the lower left. That's the lower left is the continuous corrugation, where it's continually wavy. The one on the right is corrugated every X amount of inches. So there's two different types of attachments for those roofs. For the continuously corrugated one in the lower left, as you can see, that attachment sits over the top of the corrugation and then lags into the valley. And there's a seal that you can just about see there under that attachment to make sure that it's watertight. For the other type of corrugation, that top left photo shows you a product that lags through that corrugation, not on the peak, but just in that flat area. And then there's a seal there, as you can see, and then you put your L-foot on top. And that's what's used in that right-hand photo right there. So we can deal with lots of different roof types. Corrugated roofs are typically for outbuildings, pole barns, things like that. If for some reason your home has a corrugated roof, and I have seen that, most installers will pass on that, because even though as good as these seals are, there's always the concern that it's not as good as a comp roof where you have this full flashing under there, or it's not as good as a standing seam metal roof, because you still have to penetrate the corrugated roof type, and it's just too much of a risk on a home to penetrate that type of roof. So most people will pass on that. But again, it's very rare that you're going to see corrugated roof on a home. What about roof age? How old is your roof? Is it too old for solar? It's always great to see a new roof when people want to go solar, because that's your best bet. If you think about it, your solar system, the modules and the inverter will probably be warranted for 25 years. So it's best to have a new or newer roof to match that system life. So if your roof's going to last for 25 years, well, your solar's last for 25 years. So it matches up nicely. According to solar, the Energy Trust has a specification that you have to have at least 10 years of life left just to get their incentive. That's been in place for a long time. I always thought that was a little too, I don't think that's long enough. I think that you really need at least 20 years, just to because it turns out it's very, very expensive to take a system down and put it back up. I'll talk about that in a minute, but let's just continue with roof age. That photo on the right, that roof is about 8 years old, and as you can see, I don't know if you can see it, but there's a slight wear at the edge of those shingles, and that's fine. That's typical. The granules that you see on roofing materials, that's your wear layer. So over time, they do wear off, which is why sometimes if you look in your gutters, it's filled with sand, or basically it's these little granules. So that's not a big deal. This roof is fine. I would install on that. However, if you go to the right, this roof here had a bunch of these little spots. You can see the spot in the middle where the granules are just really worn off. I found out that roof was probably about 15 years old or so. And yes, it could probably be up there another 10 years, but that means you'd have to take the system down and put it back up. I always recommend folks get an independent person to take a look at that roof to see what they recommend. Because even though I've done roofing, I've been trained in roofing, I would prefer somebody with much more experience to take a look at some of these roofs, because I don't want to be wrong about this. You can even see on that photo on the right, if you look carefully in the very middle, there's some of the fiberglass backing you can even see there. So that roof really should be replaced to go solar. I did mention the expense of taking a system down and putting it back up. When I started 14 years ago, we didn't think it was a big deal, but over time we learned, it turns out the reason it's so expensive is all the attachments typically get ruined. So suddenly you need all new attachments to put it back on. We've also found out that if the system's up there for a fairly long time, the racking might not come apart in such a way that it's reusable. Like a bolt might break, a clamp might break. And the problem with that is over time, the manufacturers change their material, so you might not be able to find it. So suddenly you might need some new racking. And finally, you also might need new wiring, depending on how well the old wiring came down. So at the end of the day, it's almost better to just take the system down and put a new one back up. Because what's good about that is suddenly you get the 30% federal tax credit again, and any other incentives that might be available. And that's I would say in the last 8 years, that's pretty much been the standard that folks are doing. So get a new roof, start fresh if you can, and then put your system up there. So roof structure types, I mentioned earlier on, the specialty code is really, well, not concerned, but really dives into roof structure. And there's two basic types. There's what's called stick-built and pre-manufactured trusses. That's a generality, of course, but that's really what it comes down to. On this slide here, on the left is your typical stick-built, where you have rafters, ceiling joists, and that horizontal piece at the time is called a collar tie. And on the top left, that's a very typical construction for homes. Well, even now, of course, but pre-1970, I would say, homes were all constructed in a similar way. That lower left-hand, what I'm showing there is well, they're calling it an attic truss. And that's basically those small little vertical pieces in the attic. Sometimes that's called a knee wall, where you actually have a wall up there. So if anyone of you live in a home, a two-story home that's pre-1970, you might have a room upstairs that has that, a section of slanted ceiling. Well, that's what you're looking at right there. That's actually a plus when it comes to the code, because that can help get it into what's called the prescriptive path for a structural approval. On the left, we're seeing pre-manufactured trusses. So after 1970, the industry started making these. And you've probably seen this going down the highway, a big truck with all these trusses on it. And then they hoist them up to on the roof, and that becomes your roof structure. It's got this sort of webbing up there, and it's got those plates that are nailed together. So if you look in your attic and you see something similar to that photo in the lower right, your roof structure is what's called will be prescriptive, and there won't be any issues. So you're good to go if it looks like that. But let's go back to that left-hand side where you have where you don't have that pre-manufactured truss, because then you come into an area that's where they're talking about the span. So from a structural standpoint, they want to know if that roof can hold the additional weight for solar. So what they're saying is, now there's a lot going on in this slide. I do understand that, but let's go to the left for now. If you look at that drawing, and if you look at the top, you see where it says rafter spans per tables. So when they're talking about rafter spans, they're talking about the horizontal distance between 2 points. So in this case, the first span is where the rafter attaches to that left outside wall, and then it's got that purlin brace that's sort of at an angle. Okay, that's your first span. That's a particular distance. Let's say it's 5 feet. The second span is that horizontal distance from that purlin brace or knee wall to a center line of the ridge. Okay. Now, if you look at the other side, there is no brace, so you're on the right side of that roof. There's no brace, so that the rafter span will be the total horizontal distance from the center line of the peak all the way over to the right bearing wall. So that's what when your solar installer is doing their site visit, this is what they're looking for. If they peek in the ceiling and see typical rafter construction, they need to get up there with a tape measure and figure out what those horizontal distances are. I always had a little cheat sheet in my book so that I could tell right away whether it would meet the prescriptive specifications, which is what you see on the right in this chart here. It's actually it's a fairly large chart. I'll just give you a quick peek. Yeah, there's a lot of numbers. But for Oregon, at the end of the day, the Oregon Solar Specialty Code, even though it puts all of this data here, this is the only thing we're concerned with when it comes to the species and the grade is Doug fir larch number 2. That's highlighted in yellow. That's the line we're looking at. And those are the spans that the maximum span per the size of the member, whether it's a 2x4, 2x6, 2x8, 2x12, 2x10. But you also need to look all the way on the right on that, on the left on that chart where the rafter spacing is 24 inches. So that's the distance between each rafter. So if it's a 24-inch spacing, you look at this chart, Doug fir number 2. Oh, I have 2x4s up there as rafters. Well, then that means the maximum span, that horizontal distance, is 6 feet 8 inches. And if you go up with your tape measure and it measures 6'7", you're good to go. If it measures 6'9", that's a problem. Suddenly it's not prescriptive, it's non-prescriptive. And when your roof is non-prescriptive, what that means is you may have to get an engineering review to find out what sort of upgrades might be needed. The unfortunate part about that is there's a cost to that. The engineering might be $800 or more. The structural upgrades anywhere between $2,000 and $6,000. So this was a long explanation on this part of it, but it's really important especially for older homes, pre-1970 typically, where you have to meet these span requirements. If you're lucky, you've got 2x6s up there, and if it's 24-inch spacing, as you see here, and suddenly that goes to 9 feet 9 inches. So as you can see, with larger rafter sizes, the spans become longer. Now that's for 24-inch spacing, but if you look at this table here, this is also part of that last table. I just cut it off and rearranged it. One of the more typical spans is 16 inches. You see all the way here on the bottom left, rafter spacing of 16 inches. That's fairly common too. And if I see that, I'm really happy because as you see, we go to, again, Doug fir larch number 2. For 2x4s, suddenly your span goes to 8 feet 2 inches. So if you've got a knee wall there, you're good to go, typically. If you have 2x6s, it's almost 12 feet. So all of these things add up to to find out whether your roof will meet the prescriptive or the non-prescriptive portion of the Oregon Solar Specialty Code. And if you're non-prescriptive, your installer will say, okay, it's non-prescriptive, it's, there will be some additional costs, and that would be, of course, your decision what to do. Sometimes people say, no, that's fine, I still want to go solar. That's important. I mean, I did, honestly, with a house I had 12 years ago, where I actually did the work myself, but I had to do a structural upgrade to my roof. All right. What about this is something that's new that's come up in the last number of years. Is we found out that squirrels especially sometimes like to get under these arrays and make a little nest or cause some havoc. So what the industry has done is it's come up with something called like a critter guard. And if you look at the upper left-hand photo, you can see like a black metal scrim around the perimeter of the array. And that attaches with clips to the side of the modules. And it's a metal scrim. It's plastic coated metal scrim that goes around the entire array to deter any little critter from getting up there. If you know that you have squirrels in your area, you see them, or if you've got trees that are close, it's probably a good idea to consider that. It doesn't cost that much. There isn't an additional cost to it, but it's if you do it at the time of the installation, it's a lot less expensive. Because if you figure, I don't need that, then later on you think, oh, maybe I do, it may cost 3-4 times as much, only because you suddenly it becomes a new project for the installer. They have to get somebody out there. It just takes time. Whereas if they do it when they're on site, it's just part of that initial project. If you, on the right, you see a snow guard. One of the things that we found is in high snow areas, especially if you have a metal roof, snows just get to slide right off. And if you have a steep roof, if you have solar modules, of course they're glass, so snow's going to fly right off of those as well. And we've had a few instances over the last number of years where actually one time it did damage some of the modules because it slid off of one level to a second level, and a couple of modules got slightly damaged. So snow guards are thought if you're in a high snow area and you have especially if you have a steep roof. Some other considerations, your solar installer hopefully will be running your conduit through the attic, assuming you have an attic space. Again, aesthetics are one great reason to do that. Always ask them to do that. It takes them a little bit longer, but honestly, not that much longer. It's encased in metal, flexible metal conduit, which is quick. It's very easy to run up in the attic, and it's also they have to put these cautionary labels on it so that people know exactly what's going on. So that's your DC or your AC run to the main service. What you see in the middle is basically, I wanted folks to just remember this equipment does take up some space. That was my house, and that's the service, obviously, and on the that little box to the left of it is the DC disconnect. Initially, I had the inverter was also in between there, but we actually took it out and put it on the inside of the home because I changed the system. But just be aware that your installer should let you know that, okay, we will need some space here. And what about debris on the roof or trees on the roof, as it were, which is unfortunate, of course, but we just went through a storm a number of weeks ago that really created a lot of damage around town. A couple things is because it's a permanently attached fixture to your home, it is covered by your homeowner's insurance. However, you do need to tell your insurance agent that you're putting up solar so they can list that on the policy. Debris in general, I always tell people say, what about maintenance? And honestly, I've had solar for 12 years now, first on one house, then on this house. and there's been almost no maintenance. I've never washed them at all, and I haven't seen any diminished production over the years, even during the year, because I've got monitoring on my system, and I really look at it every day, which is kind of crazy, but that's just me. And but I do tell people at least look at it once a year, or if not more. Just, maybe there's a branch up there that's just got stuck up there, and the wind's not blowing it off. That will decrease your output a bit. Of course, hopefully everyone's getting monitoring with their systems. You definitely should get monitoring, and it should be module level, meaning each module, you should be able to see the output for each solar module. That too will alert you, hey, this one's producing a lot less than all the others. What's going on? You go take a look, and yes, there's a branch on it. And you might have to get up there or get someone to get up there to take that off. I also suggest that since most roofs are obviously at an angle, you can see underneath the array as well to see if there's anything going on under there. I had a branch stuck under. Oh no, actually, I had someone do work on my HVAC system. They put up a new. I forget what they did, but they their caulk gun got stuck under the array. I don't know how that happened, and that was causing some blockage up there for debris to flow freely, and I was able to get that out of there. So things happen, is my point. But yeah, always take a look at your system. So that's my presentation. I'm wondering if there are any questions from anyone in the audience.
Mark, if can you look in the chat? There are a few good questions in the chat there.
I will do it.
Answer a few along the way, but somebody wants your take on Tesla solar roofs.
Oh, Tesla solar roofs. So my take. So the technology for the roofing, the roofing solar types is it's getting there. The Tesla, I've seen one up close. It looks pretty cool. However, the output of those roofs, or each roof panel, is about half. What am I trying to say here? So if you compared the same square footage of a crystalline silicon, module, a standard one, with the same square footage of your, let's say, Tesla roof, the output of the Tesla roof per square foot would be about half. That's only because they use a different technology. It's called thin film technology. It is getting better. It was half probably 10 years ago. It's not quite half nowadays, but the production is a lot less. That's the first thing. The other thing is, I've heard wild cost estimates, sometimes 4 times the amount. That includes a new comp roof. So lots of companies are coming out with these. I think it's a great thing. I just think that it's just still very, very expensive. And I've seen solar roofs come out. They're out for a year, and suddenly they disappear because the technology just wasn't there. It also might be difficult to get someone to install it, because I don't even know how to install it. I have no idea. And I've talked to a couple of roofers around here, and no one seems to be interested in it at this point. But sometimes, sure, they're just very expensive. Okay, so how do you find the rafter when looking on the roof? There's a couple of ways to do that. If you've got rafter tails coming out, you can line it up like that. You can drill into the roof and try to find that rafter. That's pretty typical too. But once you find one rafter, since they're typically very evenly spaced, it's easy to find the others, and you typically don't need to do a lot of drilling anymore. So if you drill and miss the rafter, so if you think about that flashing I was talking about, well, suddenly the flashing will cover that, and any sort of a hole that they put in the roof has to be flashed with an aluminum flashing, just like a roofer would do. So that's not a big problem. You see, Tesla solar shingles are expensive. That, yes, indeed. Can rebates cover a portion of the re-roofing costs? I'm assuming that would be, I think the question there would be the federal tax credit. There are some solar companies out there that, unfortunately, are telling customers, oh, you can take the 30% federal tax credit on your roof, your new roof, which is absolutely not true. In fact, I have a letter, an IRS letter that states that specifically. It said, roofs are not eligible for the 30% tax credit. On the commercial side, there is a carve out for that if you have bifacial solar modules and like a white TPO, but that's completely different. But for residential, the answer is unfortunately no, you can't do that. The efficiency of panels have improved, get more energy from production, same area. That's Linda, thank you for that. Yep, that's great. That's true. So for example, when I did my first project back in 2011 on a different home, those solar modules were, I think, 235 watt output. And then when I put these up 4 years ago on my house now, these are, I think, 385 watts. So yes, the efficiency has gone up. However, I would also say that the size of the modules has also increased slightly. So yes, the efficiency is getting better, but that combined with a slightly larger module is why we're seeing these leaps and bounds in wattages. Let's see. A 2022 article suggests that Tesla isn't supporting the solar roof well. That's interesting. I'll have to read that. Yeah, I'm definitely going to read that. Let's see. Michael says I paid $16,000 in 2018 for my 3.6 kW roof PV. I doubt that taking it down and putting it back up would cost as much as a whole new system, even with a 30% incentive. Well, let's take a look here. So 3.6, let's see, 16,000. That's $4.44 a watt for that system. I don't know. That's a good question, Michael. I think that it would probably cost about $3.75 to $4 a watt. So if you bought a new system, it would be less expensive per watt. So it might be a wash. However, on the upside, you'd be getting a much higher wattage module. So you'd be saving more money on your electric bill. It might be something to look at. Yeah, I would definitely take a look at that because it might be worth your time. Edwards, thanks for showing the span limits. Yeah, so that's, yeah, it takes a little bit of thinking to understand that, but it's something if you're really into doing it, evaluating it for yourself, it's pretty easy to do. Let's see, Michael said, but then who asked for bids to taking system down and back up? Original installer was bought out by an out-of-state company. Michael, you're basically, you'll just have to call around to see who's interested in that. Some of the local installers, you've got Elemental Energy, you've got A&R Solar, there's a Sunbridge Solar, they might be interested. What I'm finding is some solar companies, as they've grown, they're taking on more of what's called O&M work, operations and maintenance, because they're realizing, oh, these systems are older now, people need help. So some of these companies might be interested in doing that work. It's just a matter of, making some calls and say, this is what I have. Can I get a quote for that? Who pays for the part and labor cost solar PV array repair, like replacing a module due to a pre-transfer? So what Edward's asking, that's a warranty question. So installers will give you like a bumper to bumper warranty for X amount of years. Let's say it's 10 years. What that means is, if a module breaks, they're going to go back to the module manufacturer, get a new one, and then they will take care of taking it off and putting it back up. That's under their warranty. If it's after that 10 years, let me back up a bit. If it's a tree branch, that might fall under your homeowner's insurance. That's the first thing. But the warranty for a failed piece of equipment, that'll fall on on the installer and or the manufacturer. But if it's damage, that's going to be a homeowner's insurance thing. So just want to make that clear. Do you know if all AHJs, AHJ is the authority having jurisdiction, meaning who's your city or county permitting authority, are they generally strict or lenient on battery placement and spacing rules? So what Edward's asking about is battery. So we didn't really talk much about battery systems, but that's going to be a topic coming up next week. So a lot of the AHJs, honestly, are just sort of figuring it out because it's such a new concept for them. So my one of the things I tell installers is go by the rules. You've got to figure it out. As Edward here mentions, there's a standards for battery storage systems, and more standards actually need to happen. So the National Electric Code is doing some of that work right now, I know, and Oregon Solar Specialty Code. They're starting to think about, well, what sort of requirements do we need for battery systems, because they do take up a lot of space. Richard asks, what about installing panels on a freestanding patio cover? Structural issues? That's actually a great idea. I've seen that. I've seen people do that. Just note that patio, those sort of covers are typically not as big as a roof. Now, it could be, of course, if you make a nice big one. At the end of the day, you would just have to get that structurally, you'd have to get that permitted. So that means it would have to be an engineered structure. You'd have to submit the engineering to your city or county. So it's not a big deal. I've seen it happen. Absolutely. And there's Elemental Energy's email, website, A&R's website, and maybe Sunbridge would be another one. All right, any other questions? I'm trying to think if there's anything else I missed. I don't think I did, though. Again, when you are looking to go solar, make sure that your installer has worked locally for a while so that they understand all the requirements. They can tell you about the roof, and they're not trying to oversell you on something such as that federal tax credit. So I really appreciate everyone's attendance today.